Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, up to now we have covered all aspects of BJT and we have seen different kind of amplifiers that we can implement using BJT. In this video, we will cover one more specific type of application of BJT called as a differential amplifier. Now this differential amplifier is one of the most important building block of an op-amp. Okay, so it is basically used in op-amp. Now as the name suggests, what is this differential amplifier? Basically, it amplifies the difference of two input voltages. Okay, we will have, instead of one input, we will have two inputs, and it will amplify the difference of the two input voltages. Okay, now there are two possible output. If you see the figure here, we have applied one input at the base of transistor Q1, the other input at the base of transistor Q2, and one output is taken from collector of Q1 and the other output is taken from collector of Q2. That means there are two inputs and there are two outputs. Now, if V0 is taken as the difference of V01 and V02, it is called as balanced output. That is, the output voltage is the difference of the two voltages. If V0 is just taken as V01, in differential amplifier we call it as unbalanced output. Similarly, if both inputs are used, it is called as double-ended. If one input is used, it is called as single-ended. So there are basically four possible combination. Like, if I use one input and I take one output, then I'll call it as single-ended unbalanced output differential amplifier. If I use both input, double-ended unbalanced output differential amplifier. So that is how we will name the differential amplifier, based on whether or not you are using both the inputs, and secondly, whether you are taking one output or you are taking output as a difference of the two outputs. Now if V in 1 is equal to V in 2, it is called as common mode input. Common mode input implies the input signal is common to both the input terminals, and that is most probably noise. Okay, because whenever there is a noise in the system, it won't see which terminal the noise is entering. The noise will enter equally into both the terminal. So common mode input represents the noise. And if V in 1 equal to minus V in 2 equal to Vs by 2, that is called as differential input. That is, if both the input signals are opposite of each other, then differential input. If both are same, then it is common mode input. Now we are designing differential amplifier to amplify the difference. If we want to amplify the difference, we want to reject common mode input, or you can say noise. You want to reject noise and amplify differential input, right? I don't want the noise to be present at the output of the amplifier. I want noise cancellation. And if you want noise cancellation, you have to cancel the common mode input and you just have to amplify the differential mode input. So that is a desirable feature in a differential amplifier that I'll define how we will parameterize it, or I can say how we will quantify this ability. The differential amplifier must always have a ability to reject the noise and amplify the difference of the inputs. And this will be quantified in terms of common mode rejection ratio, which we will be studying later on in this video. Okay, is it fine? So just now what you have to understand, that a differential amplifier is basically designed in order to amplify the difference of the two input voltages and to reject the common input or the noise. Now let us see the first configuration, dual input unbalanced output. Dual input means both inputs are used. Both inputs are being used. Unbalanced output means only one output terminal is being used. So we are using both the input terminals but only using one of the output terminal. Now before making an analysis of AC circuit or finding the gain, we want to perform DC analysis. Now when you talk about DC analysis, we will short circuit AC source. Okay, if you short circuit AC source, then how will be the circuit looking like? Suppose I ignore the source resistance RS, then it will look something like this. And remember, I'll assume here that both transistors are identical, that is both have same base emitter drop, both have the same current gain and everything. Both transistors will be assumed to be identical. VCC RE minus VE. Okay. Now as you can see, it has two supply voltages, VCC and minus VEE. So you can also call it as dual supply. Okay, that I told you in the biasing also. In order to increase the voltage swing, we make use of the dual supply, one positive supply and the one negative supply. Okay. Now if I assume beta to be high, then I can say that base current would be 0. So here the current would be 0. Now this current would be ammeter current IE. Okay. And this current would then be 2I. This will be the voltage drop VB. Now suppose I apply KVL in the input loop. How will I apply KVL? Like this. So I'll write 0 minus VBE minus 2IERE equal to minus VE. From this I can calculate IE is VEE minus VBE by 2RE. Okay, that will be the ammeter current. Now we very well know then when base current is 0, the Q point ammeter current is same as the Q point collector current. Is it fine? But what we also want in DC analysis is the collector to ammeter voltage. For that what I will do is I'll apply KVL like this. So I'll write VCC minus IC into RC minus VCE minus 2IERE is equal to minus VE, which means I can write down VCE equal to VCC plus VEE minus IC into RC plus 2RE. So once I have this VCE, I can say that the Q point of both transistor is identical, IC comma VC. So that is how we perform DC analysis on any kind of amplifier. And remember, this DC analysis is independent of the nature of amplifier, that is Even if you are taking one output or you are taking both the outputs, you are applying one input or you are applying both the inputs, it is independent of that. So that means the Q point is independent of the nature of differential amplifier. It is same for all four possible combinations of the differential amplifier. Now we will proceed to the AC analysis. Now we say that the output voltage of amplifier is made up of two voltage. Now what are these two voltage? VD is called as differential input and VC is called as common mode input. Similarly, this AD is called as differential gain and AC is called as common mode gain. That is what I mean to say here is that your differential amplifier is amplifying the differential input as well as common mode input. I told you what is meant by common mode input. It means the noise input to the amplifier. Since both are being amplified, the output has been written as a superposition of both the things, that is the differential and the common mode. Now how you will write this differential input? This differential input is the difference of the two input voltages at both the inputs. What about this common mode input? It is average of the two inputs. Remember, differential input is the difference of two inputs and common mode input is the average of the two inputs. Now suppose I want to find these two gains, AC and AD. So if I want to find the common mode gain, ideally this common mode gain should be 0. That means I don't want the noise to be amplified. I only want the difference to be amplified. So ideally common mode gain must be 0. But here I am saying suppose we have common mode gain AC. So how you will find it out? You will find it out V0 by VC, but when differential input is 0. If the differential input is made 0, then V0 by VC is common mode gain. How can you make differential mode input as 0? If I keep these two inputs same. So for common mode gain, V in 1 is kept equal to V in 2 equal to Vs, which means the differential voltage is 0 and common mode gain is the average. Both are equal, Vs plus Vs by 2, that is Vs. So what you will say? AC will be equal to V0 by Vs when both the input voltages are equal to Vs. Now I will show you how to draw the AC model of the BJT here and find this common mode gain. So is this clear? I am removing this. Okay. So what I have understood is I have to apply the same input voltage at both the terminals. So let me start from the first one. This is Vs. This is Rs. Okay. Now we have reached the base terminal of the first transistor. Between base and ammeter, what we have? Between base and ammeter we have a resistance R pi and we consider a current IB1. Now this is the ammeter terminal. Similarly, between collector and ammeter we have a current source beta IB1. I am ignoring the output resistance R0. Now for AC analysis you will ground this VCC. So this RC will be connected between collector and ground. So RC will be connected between collector and ground. Is this fine? This is your V0. Because we are talking about unbalanced output, so there is no output terminal here. This value will be equal to V0. Now let us talk about the second transistor. I will start drawing it from the right hand side. First we have Vs here. I told you both input must be equal to Vs. Then we have source resistance Rs. We reach the base of the second transistor. Between base and ammeter, this is your ammeter terminal, we have resistance R pi, and this current is IB2. Now between collector and ammeter, we will have a current source beta IB2. Then similar to the first transistor, the collector terminal will be grounded by means of a resistance RC. But there is no output terminal from here. See, there is no output terminal here. So RC will be connected between collector and ground. Now see, the ammeter terminal of both the transistors are connected together and then connected to RE. Now you will short circuit the DC supply. So this terminal will be grounded. So what I will do is, I will tie these two terminals together and I will connect one resistance here, RE. Okay. Now see, I want to find the gain of the amplifier, that is V0 by Vs. So what will be the current here? The current here will be 1 plus beta IB1. What will be the current here? 1 plus beta IB2. So by KCL, the current in this resistance would be 1 plus beta IB1 plus IB2. Now we know that both transistors are identical. Both are identical, right? Also both have same source. Is it fine? Both have the same value of source. If both are identical and both have the same source, can I say the current in both the transistors will be same? So that means this current would be 2 into 1 plus beta into IB. Okay. Because both transistors are identical, their supply is identical, so their currents would also be identical. Now if you want to find out this Vs, I will apply KVL like this. So I will write Vs is IB1 is IB, Rs plus R pi plus 2 1 plus beta IB RE. That is your source voltage Vs. What about output voltage? This is output voltage, but this beta IB current is flowing like this. So the output voltage polarity will be negative. So it will be minus beta IB RC. Now if you want to find out the common mode gain, the common mode gain I wrote as V0 by Vs when both voltages are equal. So IB will get cancelled in both the equations. So what you will get? Minus beta RC whole divided by Rs plus R pi plus 2 times 1 plus beta RE. Now this Rs, R pi and Re are of the same order. That is, all are like 2-3 kilo ohm resistor, but this Re is multiplied by 1 plus beta. Due to this 1 plus beta, this entire term is much larger than the rest of the expression. Are you getting my point? Rs, R pi and Re all are in kilo ohm, but due to factor of 1 plus beta into Re is very high. So this gain is almost equal to minus beta Rc by 2 Re 1 plus beta. If you say that beta is very high, 1 plus beta will be approximately beta. So this gain will be minus Rc by 2 Re. Okay. So that is the gain offered to the common mode signal or the noise signal. So what you can say here is that the common mode gain is minus Rc by 2 Re. But ideally what I want? Ideally this common mode gain must be 0. To make it 0, either Rc must be 0 or you can say RE must tend to infinity. Now how can you make RE equal to infinity? By using a constant current biasing. In constant current biasing, what did I tell you? In constant current bias, we connect a current source at the ammeter terminal. Now when you will perform AC analysis, in AC analysis, DC voltage source is short circuited and DC current source, this current source will be open circuited, and due to that this RE will be infinity. Always remember, when we talk about AC analysis, we have to make DC source equal to 0, and DC voltage source becoming 0 means short circuiting, and DC current source becoming 0 means open circuiting. So if you replace it by a current source, then in AC analysis this current source will be open circuited, and if this current source is open circuited, then you can say that we have achieved RE tending to infinity. Also one more thing, in constant current bias I told you it has most stable Q point, right? Q point cannot change. That means it will always act in the or work in the active region, or it will always work as an amplifier. Is it fine? Now how can you implement this constant current bias? That also I have told you earlier that this can be done by means of a current mirror circuit. Current mirror circuit was basically being used to generate constant current bias in the different parts of an integrated circuit. That means differential amplifier will not be used alone. We will make use of current mirror with differential amplifier for constant current biasing. Okay. So this is about the common mode gain. But I told you that V0 comprises of two elements, AD-VD plus AC-VC. How to find this differential gain AD? It will be V0 by VD when VC is 0. Now VC was equal to V in 1 plus V in 2 by 2. How can you make it equal to 0? This can be made equal to 0 if both are negative of each other, that I am telling Vs by 2. Which means the differential voltage, which was V in 1 minus V in 2, it is equal to 2 V in 1 equal to Vs. Okay. That means we can say that AD is equal to V0 by Vs, but when both input voltages are negative of each other and equal to Vs by 2. Now using this definition I will try and determine the voltage gain or the differential mode gain. So let me redraw the AC equivalent of the amplifier. So as earlier, I will start drawing from the left hand side. Okay, this will be Vs by 2. Now suppose I am ignoring Rs. Between base and ammeter, I will show a resistance R pi. This current would be IB1. Now this is the ammeter terminal. Between collector and ammeter, we will have a current source beta IB1. Then this collector was connected to a resistance RC. This was V0. I am drawing the exact same circuit that I drawn earlier like this. Okay. Then we will start drawing from the right hand side. But this source here will now be minus Vs by 2. Both the sources must be opposite. Between base and ammeter, we will again have a resistance R pi, and the current here must be IB2. Now this is ammeter terminal. This current source here will be beta IB2, and then we will have a resistance here RC. Now the ammeter of the two amplifiers or the two transistors are connected together, and they are connected to a resistance RE. Now see, both the transistors are identical. Both transistors are identical. But what is happening? Their inputs are opposite of each other. If the transistor is same but the input voltage is negative of each other, can I say that the current will also be negative of each other? Okay. If you apply the negative voltage to a same circuit, you will get the negative current. So what is the current here by KCL? 1 plus beta IB1. What is the current here? 1 plus beta IB2. But IB1 and IB2 are negative of each other. So when you take KCL here, 1 plus beta IB1 plus IB2, it will come out to be 0. Okay. This current will come out to be 0. That means here there will be 0 volt. I into R. So this voltage will also be 0. Is it fine? So here the net current going into RE becomes 0 because both the currents are negative of each other. Now what you can do is you can apply KVL here. So what you can do is Vs by 2 equal to IB1 into R pi, because this terminal is 0 volt, or you can say grounded. Then V0 is this polarity, but due to this beta IB1, the polarity induced will be negative. So you can say V0 is minus beta IB1 into RC. So that means if you write Vs, Vs is 2 IB1 R pi. So if you find out the differential gain, which is V0 by Vs, if you take the ratio, IB1 will get cancelled, minus beta RC by 2 R pi. We know this R pi is approximately beta RE. So that is minus RC over 2 RE. This RE is much less than capital RE. That is why differential mode gain is much greater than the common mode gain. So what we have derived is that the common mode gain was minus RC by 2 capital RE, whereas the differential mode gain is minus RC by 2 small re. This RE, small re, is around 25-26 ohm. So it is much less than capital RE because it is in kilo ohm. If the denominator is less, you can say that the magnitude of differential gain is much larger than the magnitude of common mode gain. Is it fine? And I told you, our objective behind designing the differential amplifier is to reject the common mode signal or to reject the noise and amplify the difference. So we define a factor here called as common mode rejection ratio, that is CMRR. Common mode rejection ratio is taken as the ratio of differential mode gain to the common mode gain. Magnitude we are taking. If you take the ratio of these two, it will be capital RE by small re. Now if you find out this in decibel, you will write 20 log on base of 10 ratio of differential mode gain to the common mode gain, which in our case will become 20 log on the base of 10 capital RE by small re. I have removed magnitude because resistance is positive only. Is it fine? So that means what is common mode rejection ratio? It is the ability of an amplifier to amplify the differential input and reject the common mode input. So if CMRR is high, I can say that differential signal is being amplified, whereas common mode signal is getting rejected. That is the main significance of this CMRR. Okay. Now next we define a term called as differential input resistance. Now what is this differential input resistance? It is the ratio of input voltage at one terminal to the input current from that terminal when other input is 0. Or at the second terminal also you can find V in 2 by I in 2 when V in 1 is 0. So you can say it is the resistance seen from one terminal when the other terminal is grounded. That is called as the differential input resistance. Suppose I want to derive this resistance, so I am again drawing the AC model. So suppose I have a voltage here V in 1. I am ignoring RS because RS should never come in the input resistance. Between base and ammeter we will have R pi. The current here would be IB. This current would be beta IB1. This is IB1. This is the ammeter terminal. Then this resistance was RC. This was V0. Now when you design the second side or the second transistor, you ground the input terminal. Between base and ammeter we will have a resistance R pi. This current would be IB2. Then the current source here would be beta IB2. This is ammeter terminal. This is RC. Now these two ammeters are connected together. Now what I will say here is this is open circuit. Why open circuit? Due to constant current biasing. I told you in differential amplifier we make use of constant current bias, and that current source will be open circuited in AC analysis. See this circuit. What I have done is I have just grounded this terminal and I am saying this RE is infinite. Why this RE is infinite? Due to this current source. If RE is infinite, I will open circuit the ammeter terminal, which is what I have done here. Now one thing that will happen is I am removing this in order to use this space. So suppose since both these are grounded, if both of these are grounded, I will connect like this and then I will say this is ground. That means you can say that if you apply KVL like this, if you apply KVL like this in this loop, what you will say? This is plus minus, this is plus minus. What you will say? V in 1 minus IB1 into R pi plus IB2 into R pi equal to 0. So V in 1 equal to IB1 minus IB2 into R pi. But now if you apply KCL, this current is IB1, this current is IB2. So you can say IB2 is equal to minus IB1. So this is 2 IB1 R pi. So which means the differential input resistance V in 1 over IB1 is equal to 2 R pi, or you can say 2 beta RE. So that is the differential input resistance. You could have applied the source at the second terminal and grounded the first terminal. Is it fine? So that is your choice, but this resistance is always fixed. It is equal to 2 beta RE. Now we also define one more term called as differential output resistance. What is this differential output resistance? See, listen carefully. It is the resistance seen at one output terminal with the other output terminal grounded. Resistance measured at the output terminal with respect to the ground. So see, if you see from here, what is the resistance? RC. If you see from this terminal, what is the resistance? RC. That is your differential output resistance. So what is differential output resistance? resistance of the output terminal with respect to the ground, and it will be always equal to RC. So let me summarize what I have told. First of all, I have told you the significance of differential amplifier, that it is used to amplify the difference of the two voltages, and I told you the differential voltage is the difference of the two voltage, and the common mode voltage, that is the noise, is equal to the average of two inputs. Then I told V0 can be written as the superposition of the two outputs, one due to differential input and other due to common input. And then I told there are two inputs and two outputs, so there are four possibilities. In this video I have told you about dual input, unbalanced output. That is, I was taking output from only one terminal, whereas the input was applied at both terminal. So we saw differential gain was minus RC by 2 small re, and common mode gain was minus RC by 2 capital RE. And then we defined CMRR, which is ratio of AD and AC, so which was RE by small re, which is high. Okay, and it will be infinite. If this RE is infinite, RE can be made infinity by the use of constant current bias. Okay, and I also told in dB you can write it as 20 log on the base of 10 mod of AD by AC. And then I told you the differential input resistance, that is the input resistance at one terminal with other terminal grounded, it was 2 beta Re, and differential output resistance, which is output resistance with respect to ground, it is RC. So these parameters we have derived for one configuration of differential amplifier. In the next lecture what I will do is I will derive the same parameters but for other three configurations of the differential amplifier. Okay, so this will be all from this video. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series, and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/GATEAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil, and Telugu, JE channel, Computer Science, Gate Question, and Electrical Junction, Pathshala, and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these two channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like, and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.